Hello, my name is John Lambert. I'm with Benchmark, and we are the Canadian national distributor of Easy Laser. That includes digital belt alignment, shaft alignment that I'm going to go and do now, as well as geometric measurement. If you want to see more of us, please go to our website, which is www.benchmarkpdm.com, and you'll be able to get a better understanding of who we are. PDM, by the way, stands for Precision Driven Maintenance, which I think we should all aspire to when we're doing machinery installation. So my focus today is going to be showing you the system, a mid-range system, which is called the E540. As I said, it's a mid-range system, but has lots of features that you will like. Okay, I'm going to show you the simplicity of use. But first of all, let me just show you, when you actually take the detector out of the box, it comes pre-mounted on a bracket. This is the detector. It has a beam that comes out of here, and this is the detector slot. It's 30 millimeters in length, so that's almost 1.25 inches. That's a huge amount of travel. So rough alignment is easily done on this. You can actually see this one's got an M on it, which is for the movable machine, which we choose to be this side. And to mount it, all I do is hang the chain from the bracket, pass it under the shaft, and put it on the pin, tighten it up. Now, this exactly the same unit, when it's in the inverse, the beam's out on the top. There's the long detector service, and you can see it's got an S on it, and that goes on the stationary side. And to do that, you just simply hang it off the bracket, put it on the pin, and we're on. Now then, the display is already on. As you can see, it's got a few programs that we can use. This is shaft alignment. The next program is actually digital belt alignment that you need accessories to go and do. Next program is vibration. It'll take an overall vibration reading as well as a bearing condition reading, and we have a values program. Today we're going to focus on the shaft alignment and simplicity. So here's our shaft alignment programs, and as you can see, we've got shaft alignment horizontal, we've got shaft alignment vertical, we've got multi-train units, so say a motor that's driving a gearbox, that's driving a pump, we can do that, and we also have a software program. Okay, right now we're just going to go and do horizontal alignment, so I choose that. I'll just point out that as we do this, everything that you need to be able to do is prompted right here. It says enter the distances S to M, and the yellow box highlights it. So it's from the center of the shaft to the rod to the center of the rod, and I just have a little bit more than 7 inches, so I'm actually going to put 7.1 and put that in. Now by default it's just half that to give me the sense of the coupling, but this is actually more like 4 inches. So I just override it by pushing the 4 and I'm in. Now it says M to MF1, which is movable foot 1, movable machine foot 1. And I've got 2.25, 2.2, enter. And the last measurement is the distance between the machine's feet, which is 6 inches. Now, I have everything that I need in order for the machine to be able to take some readings and then calculate how much shim we're going to have to put underneath. So, now when you see them in the detector service, what I'm trying to do is I'm trying to get this to be in the center of its route, travel. And that's roughly there. Now I'd actually be happy with that because I'm under the 20th thou. I don't need to move it any more than that. The other thing that's important to me though is this. These are built-in inclinometers and we have one on each head. and they have to be within a degree. In other words, opposite each other in this plane here. So in order to make them so I have to just move the unit and that's going to be close enough. Now simply tighten them up and I'm ready to take my first reading. Now then, I only have to move this a total of 40 degrees, but for me to do this, I like to take a full sweep. So a full sweep is what I say is from 9 o'clock to 12 o'clock to 3 o'clock. I move it to the 9 o'clock position and I take my first reading. I now move it to the 12 o'clock position and I take my time, I'm not in a rush, and I take my second reading. I want accuracy, I want repeatability, I don't want speed. Bring it down to the 3 o'clock position. And I take my last reading. Now, I have all the information I need to be able to go and do an alignment. These numbers on the top are what's important to me. You can see there's a huge amount of offset. There's only half a thou per inch of angle in the vertical plane. This side of the unit is vertical. It needs to be corrected with a 28 thou shin under the front foot and 32 under the back foot. On this side, you can see it's horizontal. It's also reading live time. That's what the arrows mean. I've got 3.5 thou of offset and 3 thou per inch. That's a lot of angle. So I need to correct that. The corrections are 20 thou up the front foot and 40 thou up the back foot. Now, in order for me to do this, what I would normally do is put the shim in and then correct this, correct the horizontal live time. Before I go to that, let me just show you one other thing. Under here, this is my toolbox, and if I come up, I can actually input a tolerance so I know whether I'm in spec or not. Now, it's based on RPM, as we all know, and 1725 is the most popular RPM on the market. This is 1000 to 2000, so that's what I want to go. So I'll scroll down and I'll put it in. As you can see, it's out. Yes, the angle is okay already on the vertical plane, but everything else is in the red, so it's out. So what I will do, I'm going to turn it over this side so you can see it. And it's gone live. I'm going to loosen off my machine. And I'm going to put the right amount of shim under the feet. Okay, so now I've actually made the corrections for the vertical plane, so now I need to be able to move the horizontal. Okay, so look, I'm going to purposely make a mistake. It's got 40 thou. I'm going to push it the wrong way. It's not a problem. I stop doing that, I start bringing it the correct way. It's easy. Easy laser. Okay, 7, 6, 5, 4. Okay, a little bit more. Oh, that'll do. And you can see the horizontals come into alignment, but I really do need to remeasure. So this button here, I press the button and it prompts me. It says remeasure the coupling. I say yes. I may as well start right there. I can start anywhere in the rotation, so this is good at any place. It's one reading. Go up to the top. 2 readings. Taking my time. 3 readings. And as you can see, it's perfect alignment. Again, this is the vertical plane. I've got 1.5 thou. 2 thou would be excellent. 1/2 thou per inch is excellent. In the horizontal plane, I've got 1.5 thou, and I've got absolutely no angle whatsoever. So I'm very pleased. But I'm not finished. One of the things that we promote at Benchmark is mad maintenance. Mad maintenance is where we measure, we analyze, we act on what we're doing, and then we document it. So I've done that. I've measured, I analyzed it, I saw what we had to go and do, I took the action, made the correction, but now I've got to go and document. So under this button, I can scroll up to my file, and for simplicity, I will make this a B, C, and I save it. Now it saves in 2 ways. It saves actually as a program in there, so you can reopen it and continue to measure. It also saves it as a PDF, which looks something like this. So we've got all the information that we need. We have our customer on the top, we have all the dimensions that we put in, and we can have our before and after measurements as we choose. So you can have it in this format and save it as for your history, and you'll be very happy.